Today, folks, we're going to be taking a look at section 7.2 in your textbook. Our objective for today is to graph and recognize inverses of relations and functions. And then we're going to be able to learn how to find inverses of functions. When we're all done today, you'll be able to do a problem much like the one I've shown here. Use inverse operations to write the inverse of the function f of x equals x minus 1/2, if that is possible. Alright, so let's get into our new material today. But before we do that, let's look at a warm-up question to get us started. Okay, here's our first warm-up question. It says x equals 3y minus 7. Now, your task in this first question is to solve it for y. In other words, get y by itself. Alright, now I want you to do the second one the same way. It looks a little bit different, but your goal is to get y by itself. Alright, go ahead and pause it at this point and do these two questions. Alright, now that you've paused it and worked through this here, let's work through these two problems together. So, in looking at our first question, it says, let me change pen colors here. I feel brown today, so we're going to lose a little bit of a brown color. Okay, so first question, it says x equals 3y minus 7. Now, our goal is to get this y right here all by itself. So we're going to undo the 3 and the negative 7 around it. We're going to unwrap this y and get the y by itself on one side and everything else on the other side. Alright, so how are we going to go about doing that? Well, first of all, I'm going to add this 7 to both sides. Okay, so we're going to go like this. And then I'm going to get x plus a 7 is equal to a 3y. Next, I have a 3 times y. So the opposite of timesing by 3 is dividing by 3. So I'm going to divide both sides by 3. And I get y is equal to x plus 7 over 3. And in doing so, now I can use my symmetric property. And I'm going to flip this around so it looks like y is equal to x plus 7 over 3. Okay, there's our first question. Now let's take a look at the second. In the second one, we have x equals y plus a 5 over 8. Now, the first thing I need to do, well, remember what our goal is. We have to get this by itself. So I need to unwrap that y, and in unwrapping that y, to do that, I need to get rid of the 8 first. So I'm going to multiply both sides by 8. So that gives me 8x is equal to y plus 5. Now I can do what? If you said subtract 5, you are right. We're going to subtract 5 to both sides. So I have y is equal to 8x minus a 5. Now let's use our symmetric property. Y is equal to 8x plus 5. We get it flipped around there. And there we go. Here are our two warm-up questions worked out. Alright, so let's begin the lesson for today. Before we get into the lesson too far today, let's go ahead and begin looking at what our vocabulary, our new vocabulary for today, what it's going to be. Well, first of all, our first vocab word is an inverse relation. We're going to look and define what an inverse relation is, and then secondly, an inverse function. So, alright, so let's get underway. In this math course, we have heard the word inverse used in a couple different ways. For example, one way we've heard it is in the idea of, for example, what is the additive inverse of 3? Well, the additive inverse of 3 is going to be, what? Negative 3. And then what about the multiplicative inverse? What was the multiplicative inverse? Well, yes, of 5 it's going to be 1 over 5. Okay, so there's some ways that we have used the word inverse. Today we're going to learn a new way of using the word inverse. Today we are going to learn about an inverse function. So, in your Cornell notes on the left side, if you would write inverse relation, write the word inverse relation, and I've underlined some parts of the text that I want you to write down. Now, to graph the inverse relation, you can reflect each point across a line y equals x. Now, this is equivalent to switching the x and y values in each of the ordered pairs. Alright, so For example, if I take a relation, for example, here would be a relation. If I took the relation, for example, say 2, 3. Now remember, relation is a set of ordered pairs. Let's say I say 4, 5, and I'll give one more. How about 6, 7? Okay, so here is a set of ordered pairs. If I want to find the inverse of that, I just interchange the x and y's. So my inverse of this relation would be 3, 2, 5, 4, and 7, 6. Okay, so that would be the inverse of each of these ordered pairs. That would be the inverse of this relation. Okay, let's try an example. I've given you a set of ordered pairs. Here's x and y in a table, and it shows 0, 2, 1, 5, 5, 6, 8, 9. Now, what we want to do here is we want to find the inverse of this relation here. So, what would be the inverse of, for example, 0, 2? Well, according to what we just stated on the previous slide, it would be what? Yes, 2, 0. So, if I cover this up, 2, 0 would be the inverse. Okay, and I think you probably have the idea. So what would the rest of them be? Well, instead of 1, 5, it would be, yes, you said it, 5, 1. Okay, and so on. We can do that for the rest of them as well. All right, so what we do is we actually just interchange your domain and your range values. Now let's take a look at the graph of this. If you graph the first one here, it would look something like this. Okay, so here would be the graph of it, and we're going to connect each of these dots. So, you know, we have 0, 2, and we have 1, 5, and so on and so forth, and then we're just going to connect the dots. Now, what would it look like if we were to graph the inverse? Well, let's go to the next slide and see just what that would look like. Okay, here's what it would look like. So, here you have, for example, 2, 0, then you have 5, 1, then of course you have 6, 5, and so on and so forth, and then you connect it. Now notice here, if I draw the line y equals x right down the center, notice the distance you are from the line to the 0, 2 is the same distance we are from this line to 2, 0. Same here. Notice that the distance you have from the line to 1, 5 is the same as it is from 5, 1, and so on and so forth all the way. So in other words, the inverse is going to be a reflection across the line y equals x, and that gives your inverse. All right. Now let's you try one. So go ahead and pause it. And what I want you to do is I want you to find the inverse relation in a table, and then I want you to graph both the initial one right here, and then I want you to graph the inverse relation as well. All right, go ahead and pause it. All right, now that you've paused it, and let's check your answers here. Here's what your relation should have looked like. All right, and here's the graph of your initial, that's this set right here, your initial relation. All right, so let's take a look at the inverse of it. Okay, here is what it's going to look like. Okay, there is your graph. Okay, so again, you see your initial relation, and then you see your inverse relation. And notice here that up here your domain was between 1 and 6 and your range between 0 and 5. But remember, the inverse switches those, so that means your domain for the inverse is going to be between 0 and 5, and your range is going to be between 1 and 6 inclusive. All right. Let's go look at another example. Anytime you have an inverse function, there is a certain terminology that we will use to show it's an inverse. For example, you have f of x right here. Well, the inverse is this symbol right here. So when the relation is also a function, you can write the inverse function as f inverse of x, and that's how you read that. Okay, now, simple thing here real quickly, let me just state this. This notation does not indicate a reciprocal, so don't get it confused with it being a reciprocal. Now, I want you to make a little side note here. So in your Cornell notes off to the left, put a little asterisk, and I want you to write this statement. To find the inverse function, use the inverse operations. Okay, now, what does that mean? Well, I want you to take a look at this function here that I have here in green. F of x equals x plus 6. Now, according to what we have written here today, to find an inverse function, you use an inverse operation. Well, what is the inverse operation of plus 6? Well, if you said minus 6, you are correct. So you just put a minus 6 there. So the inverse function is x minus 6. So notice, if I take an input value of 3 and plug that in for x, 3 plus 6 is 9. Now, look at the inverse. If I take this output value of 9, and we're going to plug that in as the input value of the inverse function, notice 9 minus 6 is 3. So notice your output here and compare it with your input of your original function. Alright, so you see the characteristics there? You see that relationship? Alright, let's go on and we'll look at some more examples. Okay, take a look at this one. We have x minus 2. So that means I want to find the inverse. So we're going to put f inverse of x right here. And what is the inverse operation of negative 1/2? Well, if you said plus 1/2, you are correct. So the inverse function is just going to be x plus 1/2. That's pretty much all there is to it. But let's go ahead and let's check it. In checking it, I am going to take the value x equals 1, and I'm going to plug it in here, and we're going to see what we come up with here. So if I plug a 1 in there, notice 1 minus 1/2 gives us 1/2. Okay, now, let's take this 1/2, and this time, let's plug that in for f inverse of x here. So I'm going to plug the 1/2 in here, and I plug the 1/2 in here, and then what's 1/2 plus 1? I'm sorry, 1/2 plus 1/2? Yes, you're right, it is 1. Alright, so do you see the relationship here? See the domain up here is 1, the range down here was 1, the range here was 1/2, and the domain value here was 1/2. Okay, so that check indicates and tells us that we do have, they are inverse functions. Okay, let's take a look at this example. In this example, you have x divided by 3. So you want to know what the inverse function is of x divided by 3. Remember the inverse function, to find the inverse function, you do the inverse operations. Alright, go ahead and pause it and work through this one, and then we'll talk about it here in a few moments. Okay, now that you've done this, first thing you want to do is you want to put f inverse of x here, and you're going to put the x here, and what is the inverse operation of divide 3? If you said times 3, you are right. So the inverse function is f inverse of x is equal to 3 times x. Now, let's go check it. In checking it, we're going to take the value of 1, and I'm going to plug 1 in here, and we're going to see what we get. Alright, so let's go ahead and do that. So, f of 1 is going to give us, you said it, 1/3. Okay, so now let's take this 1/3 right here, and I'm going to plug that in here for x, and we're going to see if we get 1 back. If we do, then that means the inverse functions, they are inverse functions of each other. So let's go ahead and check it. So I plug in a 1/3 into here, plug a 1/3 into there. 3 times 1/3 is 1. So the inverse function does undo the original function. Let's see if you picked up on what we've been doing here. The key to this whole thing is you want to undo operations. Now, when you undo the operations, what if I put more than one operation in the same problem? Well, we do the opposite order of the order of the operations. In other words, instead of doing parentheses, exponents, multiplication or division, addition or subtraction, we do it in the reverse order. So we're going to do addition or subtraction first, multiplication or division second, then exponents, then parentheses. Here's a problem that has multiple steps. So we're going to find the inverse of this multiple step function. So in looking at this one, I have f of x equals 3 times the quantity x minus 3. Now here, what are we told to do? Well, first of all, notice that we take the variable and we're subtracting 7 from it, and then we're multiplying by 3. Now, when we undo that, I'm doing it in the reverse order. So notice I subtracted 7, then I multiplied by 3. So this time I'm going to take the variable and I'm going to divide by 3, and then I'm going to do the opposite of subtracting 7. I'm going to add 7. Alright, so our result is going to look like this. So the inverse function will be the variable divided by 3, or times by a third, whichever you want to look at, however you want to look at it. Then you're going to add 7 to it. And then we're going to check our results to make sure that they are inverse functions. And there's our check. Now you try one. Go ahead and pause the video and see if you can find the inverse of this function. Okay, looking at it, you have to ask yourself, what do you have? What is happening to the variable? Well, notice right here, you're timesing the variable by 5, then you're subtracting 7. So we want to do the inverse of that. So I'm going to do it in the reverse order, which means the first thing I want to do is I want to add 7, and then I want to divide by 5. Okay, so here's what you should have received. That's what you should have gotten. And then, of course, if you plug it in to check it, we're going to take a value of 2, plug it in. It gives us 3. We take the 3. We're going to plug that 3 in for the domain of the inverse, and it gives us 2 back. So yes, they are inverse. At this point, if some of you are scratching your head and you're wondering, what is he talking about? Let me give you a second way of doing this. And oftentimes this is the way that most students will do it. So you have 2 ways of finding the inverse functions. And the one way that I'm going to talk about now, and I want you to put a little asterisk there in your Cornell notes, you can also find the inverse function by writing the original function with the x and y switched. And then you're just going to solve for y. Okay, so pause the video a second. Make sure you get this very important note down. Okay, let's try an example. So the first thing we did is we took this function and we're going to interchange the x and y's. Okay, so here's what it's going to look like. Now, after we interchange it, then our goal is to solve for y. To solve for this, I first have to add 5 to both sides. Okay, so let's just do that. Then after I add 5 to both sides, notice I have negative 1/2 times y. So you can either divide both sides by negative 1/2, or you can multiply both sides by negative 2, which is the way I'm going to do it. And we end up getting y equals negative 2x minus 10. Now, from here, let's put it in a format where it's y equals, so we're going to put y equals on this side. Now, from here, we have to replace this y with f inverse of x. Okay, so let's go do that. Okay, so let's go ahead and do that. I'm going to replace the y with f inverse of x, and then I have negative times the quantity, negative 2 times the quantity, x plus a 5. Now, we can clean it up a little bit. And if we clean it up a little bit, we're just going to distribute the negative 2 inside, and you end up getting this right there. Now, let's graph the functions. Matter of fact, let's graph both of them. And when we graph both of them, I want you to see that both graphs are a reflection over the line y equals x. So, here's what the graph is going to look like. So, first of all, the graph in blue is the original equation. That's the one we started with. And the one in red, of course, is the inverse. So notice what's happened. If I take this function right here and I reflect it over the line y equals x, it gives me this line right there. Alrighty. So that's what your inverse is going to look like. Okay, let's go try another example. All right, you go ahead and try this problem. I want you to pause it, and then I want you to, now remember what you need to do first. Okay, and the steps are right here. First of all, switch x and y. Solve for y. Then write it in the y equal format. And then I want you to put f inverse of x in for y, and then I want you to graph both functions. Okay, so go ahead and pause it and walk through each of those steps. Alright, how did it come out? Well, let's see how you did. So first of all, you interchanged it, and there it is. Okay. Secondly, you subtracted 2, so it should look like this. Thirdly, let's see, I'm going to do this in 2 steps. You could multiply this by 3 halves, but instead of doing it like that, I'm going to multiply both sides here by 3. So in doing that, this is what it looks like. Okay, so now notice I distributed, not only did I have a 3 out here like this, but I also distributed that 3 inside, and that's how I came up with 3x minus 6. Okay, now I still don't have y by itself, so what could I do? Well, divide by everything by 2, I agree. Alright, now from here, now what's it going to look like? Well, at this point here, guys, remember you need to get it in y equals format, so let's flip this around. So it's going to be y is equal to 3 over 2x minus 3, and then one more little step, and then we're ready to graph it. So from here, what did you do? Well, I bet you substituted f inverse of x in for y, correct? If you did, awesome. Anyway, here it is. So here's your answer. That's what it looks like right there. Now we're going to graph both functions. And when you graph both functions, here's what it should have looked like. Notice here. Notice here. You see the equation in blue, and then you see the other one in red. Okay, you know the red was your original, and your blue is your inverse. And notice how they're just reflected over y equals x. In this slide, we're going to start to look at some real-world problems. Now, when we do real-world problems involving inverses, you don't necessarily need to interchange the x and the y, the domain, the range, because normally the domain and the ranges are names of specific quantities. So in the next few examples that we work, we're not going to interchange them. In looking at the first example, Juan buys a CD online for 20% off. Now, here's a key here. If he doesn't pay 20%, how much does he pay? Well, he's going to pay 80% of the price. Okay, very good. Okay, so let's go on. He has to pay $2.50 for shipping. The total charge is $13.70. What is the list price of the CD? So step number 1 is we want to write an equation for the total charge as a function of the list price. In other words, I want it to be C equals some price. So what we have to do first is we're going to put C equals, and remember, if we don't pay 20%, that means we do pay 80%, so it's going to be 80% of the list price. Now, is that our total charge? Nope, not quite, because we have to pay the $2.50 in shipping. So here's our equation. Now let's find the inverse of that equation now. To find the inverse of this equation, first thing we're going to do is we have to take and subtract over that shipping fee. So it's going to be C minus 250 equals 0.8L. So then what's the inverse of multiplying by 0.8? Yes, it's going to be dividing by 0.8. And when we do that, we get the L by itself. So L is going to be equal to the total charge, minus 250 all over 0.8. Okay, now that we've found our inverse function, let's go ahead and let's calculate what the price was before the discounted price. Now remember, we paid $13.70 for that CD, and I'd like to know what was the price of the CD prior to the 20% off. So we're going to take, and I'm going to plug $13.70 in for my C value. So $13.70 minus 250 divided by 0.8, and that gives us $14. So the list price of the CD was $14. Now, let's go ahead and check it. if I take my original equation and I'm going to plug 14 in there, and notice what comes out as the amount that I was charged. So it does check. Okay, I want you to do this one more example here. It says, let's read it together and then we're going to pause it and let you walk through it. It says, to make tea, use 1/6 of a teaspoon of tea per ounce of water plus a teaspoon for the pot. Use the inverse to find the number of ounces of water needed if 7 teaspoons of tea are used. So step number 1, we're going to write an equation for the number of ounces of water. So T is for T, and we're going to let ounces be Z. Okay, so go ahead and pause it and work this problem. Okay, now that you've gone through it, we're going to have, you should have T equals, now notice it said 1/6 of a teaspoon per ounce. Okay, so that's going to be 1/6 times Z for ounces, plus you have to put in 1 teaspoon for the pot, so that's plus 1. So that's the equation that you should have gotten. Now we're going to find the inverse of this. So when you found the inverse of it, this is what you should have gotten right here. So first of all, you subtracted 1 to both sides, and then you multiplied everything by 6 to get Z is equal to 6T minus 6. Okay, so there's our inverse. Step number 3, we're going to now evaluate it in order to find the number of ounces of water for 7 teaspoons of tea. Alright, go ahead and pause the video, plug your 7 into your inverse, and tell me what you get for the ounces of water. Alright, now that you've done this, you plug that 7 in there, and you get 42 minus 6, which is 36, so 36 ounces of water should be added to make the tea where you have 7 teaspoons. Alright, now we can just go through and we can check it to make sure it worked by substituting in there, and there's our problem. Alright, that wraps this up for today. Here's your problem set. We're going to do sections 7-2, 18 to 29, 31 to 34, so if you could write that down, and I'll see you in class next time.